Now let's take a series of examples here to see how we can attach link frames and how we can extract DH parameters as well. The first example, assign frames 0 through 4 for the shown non-planar 3R robotic manipulator. Then find the DH parameters table after putting the frames. So this is a 3R non-planar. We have a first joint here that rotates about this axis, and then the second joint that rotates about the axis that's going into the screen or out of the screen. So this is the second joint, and then the third joint here again, the axis goes into the screen or out of the screen. So this is joint 3, and then here we have the end effector at this point. We have length L1 here, and then length L2 here, and length L3 right here. Now, as you can see here, for the solution, first of all of my joints are Rivoli joints. Theta 1, theta 2, theta 3 are the variables for these joints. So I'm going to start here assigning the z-axis first, and then go back to the x-axis and then the y-axis. And I'm going to start with axes for frame 1. I'm not going to start with frame 0. I'm going to start with frame 1 and then frame 2 and then frame 3, and then afterwards I'll go back to frame 0 and then frame n, which is the end effector frame. Okay, so let me start with the z-axis. We're going to assign all z-axes along the axis of rotation for Rivoli joints, which is the case that we have, and then choose either of the two directions for our z-axis. So let's see what the first axis of rotation. So first Rivoli joint is here, theta 1, and the axis of rotation, this axis here. So I can choose my arrowhead to be either forward, going up, or going down. Okay, both of them are correct answers. So I'm going to choose it to go upwards, and that's my Z1. Okay, and then for Z2, this is my second joint, theta 2, and the axis of rotation is right at this point. And I can choose the arrowhead to be either pointing into the screen or out of the screen. So in this case, I'm going to choose it to go out of the screen. So I have some code here. I put an X for that axis if it's going into the screen, or I put a circle like this if it's going out of the screen. So since I assign my Z2 to Z2 to be coming out of the screen, you can see that I put here a little circle. Okay, so that's my Z2. And then going out to Z3, this is theta 3. So my axis of rotation again is this point right here. And I can put my axis and put the arrowhead either into the screen or out of the screen. Now, if I put it into the screen, then I'm going to create a twist angle between Z2 and Z3, which will create another a constant that I'll have to do calculations for. So it's always wise to, since both of these are going to be parallel, it's always wise to put them heading towards the same direction. So since I chose this to be out of the screen, I'm going to choose this one also to be out of the screen. Okay, so I put circle here. That means it's coming out of the screen, and that would be my Z3. Now I'm going to go back to frame 0. To assign Z0, we have to assign it such that it will cause as many parameters as possible to go to 0. In this case, it's always advised to assign it identical to frame 1. So whenever the first joint 1, is not moved or is still at 0, variable is 0, Z1 and Z0 will be identical and the frames will be identical. So that means my Z1 will be identical to Z0. So I'm going to assign Z0 to be going upwards like this. Okay. Again, this can be arbitrary, but it's always a good idea to have it such that we can cause as many DH parameters as possible to go down to 0 for this particular frame. Okay, now going to frame N or frame 4. This is the end effector frame. I don't have a joint here. but this point here is the point of interest because this is the end effector, and I'd like the kinematics to be able to be counted from this point. So I'm going to assign a frame here. I'm going to call it frame 4, and again, we can assign this arbitrary, but it's always advised to assign it so that we can cause as many parameters as possible to go to 0. So I can put the z here in any direction if I'd like to, but then that will create a twist angle here. So I'm going to assign it such that the twist angle will be 0. So that would be similar to z3. I'll put z4 right here. Okay, so that's my z4, and that would make the twist angle between z3 and z4 0. And we'll see this one once we start collecting our DH parameters. Okay, so that takes care of the z-axes. All right, I'm going to eliminate these theta 1, theta 2, theta 3 from the graph so that it can, be easier to see and it's not cluttered too much. So I'm just going to keep here the assignments of frames. Now going on to looking at the origins of each one of these frames. So I'll be looking at the common perpendicular between the z-axes. Okay, so I should be looking, for example, at zi and zi plus 1 so that I can find the common perpendicular for xi. So I'm going to start again with x1, or the first common perpendicular, which is the common perpendicular between z1 and z2. So z2 is coming out of the board right here, and z1 is this one. So they intersect. Since they intersect, then I have to look at the plane that contains both of these vectors, and that plane would be basically a plane that's perpendicular to the screen. Okay, since this is heading forward up here, and this one is coming out of the board, that means the plane that contains both of these vectors would be a plane that's perpendicular to the screen. Okay, so that means if I want my frame origin for frame 1, it has to be that point of intersection right here. All right, and then since I'm assigning x as well, the x-axis will have to be perpendicular to the plane that contains z1 and z2. So that means it has to be either this way or that way. Okay, so we have the freedom to choose the direction since z1 and z2 are intersecting. Okay, so I'm going to assign it this way for z1. Okay, and as you can notice, this line here is perpendicular to both z1 and to z2 that's coming out of the screen. Now let's go and look at x2. I need to find the common perpendicular between z2, which is right here coming out of the screen, and z3, which is right here also coming out of the screen. Obviously the common perpendicular would be a line that goes from here up to here, and that line would be perpendicular to both z2 and z3. Okay, since both z2 and z3 are parallel, that means this line can be on the plane of the screen or inside the screen or outside the screen. But of course, since this is a drawing here in 2D, I'm just going to draw it such that it goes from z2 to z3 right on the screen plane. Okay, so that means the origin of frame 2 will be right at this point, okay, which is the intersection between z2 and the common perpendicular between z2 and z3. Okay, that would be this point. And then the arrowhead should be pointing from the origin of frame 2 towards z3. Okay, so it has to be going this way. I cannot do it that way, the opposite way, because that would not be pointing towards z3. Okay, so that would be my x2 right here. All right, now we move on to the origin of frame 3. I should be looking at z3 and z4. Both of them are coming out of the screen, okay, and the common perpendicular is the line that goes from this point to this point. That would be a common perpendicular, which means that my origin of frame 3 would be right at this point. Okay, That's the origin, that's intersection between Z3 and the common perpendicular between Z3 and Z4. Okay, and that means the x-axis, x3, will be going from the origin of frame 3 and going towards Z4 axis. Okay, so that would be my x3, and it has to be in this direction because Z3 origin is here and Z4 is here, and that's the direction that it should be pointing towards. Now we go down to frame 0. Since this is our Z0, I can assign x0 to be same as x1, but then all the kinematics will be based on the ground frame, which will be right here. So I can choose this to be my origin of frame 0. But it's always advised to maybe take it down to the ground level. So I can assign my origin here, and that would also be a good solution that I can account for in terms of defining the end effector frame relative to the ground right here. Okay, so again, the ground frame can be arbitrarily placed anywhere, but I would rather place it here rather than here, so that the description of all the kinematics will be in reference to this ground right here. Okay, so the x-axis will have to be initiated, of course, from the origin of frame 0. And since I'm assigning the origin to be at this point, I can put x1 or x0 assigned in any direction, but then it's always advised to assign it similar to x1 so that we can eliminate any future calculations that may not be necessary. So I'm going to assign x0 here to be the same direction as x1 when angle of θ1 is 0. Now, as soon as θ1 starts moving, this x1 will depart and will start rotating with link 1. Okay, where x0 is going to stay where it is. Same when θ2 moves, joint 2 moves, x2 will start moving this way. Okay, and then when θ3 moves, x3 will start moving this way. Okay, now for xn or x4, again, I can put it arbitrary anywhere I want. There's nothing to, since we don't have any z5, I don't need to be having z or x4 pointing towards z5 since I don't have a fifth frame. But it's always advised to assign it such that it can create as many 0 DH parameters as possible. So if I create x3 to be going in this direction, similar, x4 to be going this direction, similar to x3, that means I'll be eliminating an angle for theta. Okay, so I'm going to assign it to go from the origin of frame 4 going up in the same direction as x3, and that would be my x4. Okay, so now we are done with the x-axis. Moving on to the y-axis, we're going to use the right-hand rule now. So I'm going to start all the way down from frame 0. My thumb is going to be on the right hand, of course, right hand side I'm going to use. My thumb will be in the z direction, and then my hand will be fully open, and all my four fingers will be towards the x direction. And in this case, if I move my four fingers 90 degrees, that would give me the direction for y, which means that y would be starting at this point, and then it would be pointing towards into the screen. Okay, so into the screen means that since I'm using this, it means that I'm going to put an x here, like assigning it to go into the screen, and that would be my y0. Okay, now for y1, I'll put my thumb on z1 in that direction, and then my four fingers on x1, and then move my four fingers 90 degrees, and that would mean my y would be towards the screen at this point. It will be going into the screen. So again, I'll have an x, which is indicator of the y-axis going into the screen. Okay, now we move on to y2. Again, the z here, I'm going to put my thumb in the direction of z2, and z2 is coming out of the screen. So my thumb is going out of the screen, and then my four fingers are pointing towards x2 here. Okay, if I move my four fingers 90 degrees, that would move from here into here, and that will be pointing towards my y2 axis. Okay, so my y2 axis will start from here and go in this direction. Okay, and this is my y2 going in this direction. Going on to y3, again I'm pointing my thumb in the right hand side in the positive direction of z3, which is coming out of the screen, and then my four fingers towards x3, and now I move my four fingers 90 degrees, which will move into this direction, and that would be my direction for y-axis. Now I want you to pay attention here. I'm going to put the y-axis first. Okay, so I want you to pay attention here. The y-axis is not along this line, and the reason for this is because this line is perpendicular to this axis, which is not what we need. What we need 90 degrees from this axis right here. Okay, so 90 degrees from this axis means that the y-axis will have to be in this direction right here. Okay, now moving on to y4. Again, I'm putting my thumb in the z direction, positive z direction, which is coming out of the screen, and then my four fingers in the positive x, which is here, and then I'm going to move my four fingers 90 degrees, which puts the y direction into this direction right here, and that will give me y for my frame assignment of number 4. Okay, so I put here the summary here for the axes that are not shown here clearly. So out of the screen axes are z2, z3, and z4, and into the screen axes are y0 and y1. Okay. Now I need to start getting into the DH parameters. So I put this quick reference that we had created before, so I can, it can help me here finding the DH parameters. And I created a table here, and I have alpha, I-1, AI -1, DI, and theta I. And then I put this line, each line here is for I, represents a link and joint pair. So when I is 1, that means I'm talking about link 1 and joint 1. So the parameters will go here. When I equals to 2, that means I'm talking about link 2 joint 2 right here. And 3 for link 3 joint 3, and then 4 for link 4 and joint 4. Okay, now I'm ready to start looking at alpha I-1 when I equals to 1. That means I'm looking at alpha 0. Okay, so I'll be looking at alpha 0. So we look here, this is the one for alpha. I'm going to look here. For alpha 0, I need to look at z0 and z1 about x0. Okay, so this is z0 and this is z1, and we're looking at an angle about x0, which is this x right here. So obviously x0 and x1 are the same line, which means that angle is 0. So alpha 0 is 0. Now for when I equals to 2, I'm looking at alpha I-1, which is alpha 1. So for alpha 1, I'll be looking at z1 and z2 about x1. Okay, so z1 is right here, and z2 is coming out of the screen. Okay, and I'm going to be looking at this angle about x1. So the angle between z1 and z2 about x1. Okay, so I'm going to put my thumb towards the positive direction of x1, all of my fingers on z1, and then I'm going to move my four fingers towards z2 and see how much is that angle that I moved my fingers with. Okay, so obviously if I put my thumb towards x1 and the four fingers towards z1 and then move them towards z2, which is coming out of the screen, that will give me 90 degrees that I moved my four fingers through. Okay, so that means alpha 1 is 90 degrees, which is what we're going to place here. Now for when I equals to 3, we're looking at alpha I minus 1, so alpha 2. Alpha 2, we have to look at Z2 and Z3 about x2. Okay, Z2 is coming out of the screen here, and Z3 is coming out of the screen here, and we're going to look at this about x2. x2 is right here. Okay, so if I put my thumb towards x2 and my forefingers towards Z2 and go with my forefingers from Z2 to Z3, obviously they are the same direction, both of them are coming out of the screen, which means that the angle between them about x2 is 0. So that means alpha 2 here would be 0. And then we look at when I equals to 4, looking at alpha I minus 1, that means alpha 3. So I'll be looking at Z3 and Z4 about x3. Z3 is here out of the screen, and Z4 is here out of the screen, and I'm looking at the angle between them about x3, which is right here. So I'll put my thumb towards x3 and my forefingers towards Z3 out of the screen, and see how I can go with my forefingers towards Z4, which happens here to be in the same direction as Z3, which means that the angle between Z3 and Z4 about x3 is also 0. So alpha 3 is 0, and that's what we're going to put here. All right, this finishes the alpha column right here. Moving on to the A now, this is the offset. So if I'm going to be looking at when I equals to 1, I'm looking at AI minus 1, so A0. This is the chart for A. I should be looking for A0, I should be looking for Z0 and Z1 along x0. So this is Z0 and this is Z1. Okay, and I'm going to be looking at the distance between them along x0. This is x0. Obviously Z0 and Z1 are on the same line or the same position along x0, which means that that distance is 0 between these two z axes. So that means my A0 is 0. Now when I equals to 2, I'm looking at I minus 1, that means A1. So A1, I'll be looking at Z1 and Z2 along x1. Okay, so Z1 is right here, and Z2 is coming out of the screen. Okay, and then x1 is right here. So if I look at the distance between Z1 and Z2 along this line, obviously they intersect, so that means the distance is 0, which means that A1 here would be a 0. Alright, now when I equals to 3, I'll be looking at AI minus 1, which means that I'm looking at A2. For A2, I'll be looking at Z2 and Z3 along x2. Z2 is right here coming out of the screen, and Z3 is right here coming out of the screen. And I'll be looking at the distance between Z2 and Z3 along x2. This is x2. So I'm going to be looking at the distance between these two axes, Z2 and Z3, along this line, x2 line. And obviously there's a distance here, and that distance is L2, as we see right here. Okay? So that means A2 will be equal to L2. All right. Now, when we have I equals to 4, I'll be looking at AI minus 1. That means A3. So for A3, I'll be looking at Z3 and Z4 along X3. We come here. This is Z3 coming out of the screen. This is Z4 coming out of the screen. And we're looking at the distance between them along X3, which is this line right here. So from Z3 to Z4 along X3 would be this distance. And that distance is L3, as we see right here. So that means A3 will be equal to L3. Okay? And that completes the second column, which is the A column. Now we move on to the D column. When I equals to 1, I'll be looking at di, which means I'll be looking at d1. This is the D chart. So for d1, I'll be looking at x I minus 1, that means x0 and x1. Okay, so for d1, I'll be looking at x0 and x1 along z1. So x0 is right here and x1 is right here. So I'm looking at the distance between them along z1, and z1 is right at this line right here. Okay, so obviously the distance between x0 and x1 along z1 is this distance, and that would be L1. Okay, so that means my d1 is equal to L1, as you see here. Again, remember, all of these two columns are constants, okay, no variables. And since we have all three joints are revolute joints, that means we expect that all of the D here, the D column, all of them are constants. Okay, so now when we go for I equals to 2, that means I'm looking at DI, which is D2. So for D2, I'll be looking at X1 and X2 along Z2. Okay, so X1 is right here and X2 is right here along Z2, which is right here coming out of the screen. Okay, so both of these lines intersect, X1 and X2. So the distance between them along Z2 would be 0. Okay, so that means D2 will be 0. I'm going to put here. All right, now when I equals to 3, I'm going to be looking at D3. So for D3, I'll be looking at X2 and X3 along Z3. This is X2 right here, and this is X3 along Z3, which is coming out of the screen at this point. Obviously, this X2 extends, it's a line, and it intersects with X3. So this means that the distance between X2 and X3 along Z3 would be 0 because both of the lines intersect right at this point. Okay, so that means D3 would be 0 as well. Now when I equals to 4, I'm looking at D4. So for D4, I'll be looking at X3 and X4 along Z4. X3 is right here and X4 is right here along Z4, which is right here coming out of the screen. Obviously this line intersects with this line, and they're obviously the same line. So that means the distance between them along Z4 will be 0. So that means D4 will be a 0. Okay, now we're done with the third column, going on to the fourth column, which is the thetas. And for theta, when I equals to 1, theta I would be theta 1, and this is the chart for it. So for theta 1, I'll be looking at x0 and x1 about z1. This is x0 and this is x1, and I'm looking at the angle between them about z1. This is z1 right here. Okay, so obviously the way they look right now, it looks like the angle is 0, but as soon as you start moving joint 1, this x1 will move along with the first link. Okay, so this will start rotating about z1 axis. So that means this angle here is a variable angle. Okay, I cannot take it the way it's drawn right here. The way it's drawn, the angle seems to be 0, but as soon as you start moving that joint 1 about this axis, this x1 will move along with it, and it will create an angle between x1 and x0 about z1. Okay, so this angle is a variable, and I'm going to call this variable theta 1, which we're going to put right here. All right, now when I equals to 2, I'm going to be looking at theta I, which is theta 2. So from here, theta 2, I need to look at x1 and x2 about z2. x1 is right here, and x2 is right here, about z2, which is coming out of the screen right at this point. Okay, so obviously here, it looks like there is an angle between x1 and x2 about this axis, Z2, that's coming out of the screen. But again, this angle is not a constant angle. Okay, as soon as I start moving joint 2, okay, this whole link will move, and it's going to move x2 along with it, because frame 2 is attached to link 2. Okay, so once this moves, x2 is going to move along, and the angle between x1 and x2 is going to change. So this means that this is a variable, and this variable is the same as theta 2 for this joint. So I'm going to call it theta 2, and I'm going to place it right here. Now when I equals to 3, I'm looking at theta I, which is theta 3. So for theta 3 here, I'll be looking for x2 and x3 about z3. So x2 is right here, and x is 3 right here, about z3, which is this axis that's coming out of the screen. Okay, now imagine this line here. Of course, you can imagine it extended. It can go indefinitely here. Okay, so if you extend this line up to here, you can see that there's an angle right here between x2 and x3, but this angle is not constant. It changes as theta for z3 is moving. Okay, so once z3 moves, the x3 will move with it because it's attached to frame 3, which is on link 3. Okay, so the angle between x2 and x3 is a variable angle, and that angle about z3 would be changing as we move joint 3. So I'm going to call this theta 3, and it will be right here. Right, and then for the last element, when I equals to 4, I'm going to be looking at theta I, which is theta 4. So for theta 4, I'll be looking at x3 and x4 about z4. This is x3, and this is x4 about z4, which is right here coming out of the screen. Okay, so if you extend x3 all the way up to here, it's kind of matching x4. Okay, and we need to find the angle between them about z4. Now remember, z4 does not have a joint here. There is no joint, so there is no motion here, the rotation. There's no rotation that would cause this to move. Okay, so x3 and x4 are always in the same direction. They never change. The direction between them never change. Okay, they're always the same direction as each other. Okay, so the angle between them, obviously between x3 and x4 about z4, is 0, and that's constant. The reason it's constant is because we don't have a joint right here. Okay, so that means theta 4 here would be a 0, so we're going to put a 0 right here. Okay, so this completes my DH parameters table. I have all parameters for all the joints and link pairs, and as we can see here, you know, we can use these DH parameters later on that we're going to see in later slides to make the forward kinematics as we go to the next step.